Hello, my name is Thomas Rodriguez, and I will be going over Lab 5 for Physics 2211. So to introduce this lab, what I did was I observed a video of a man who held a slinky off the ground with his hand, and then he dropped it to see what the kind of motion that the slinky would have until it hit the ground. And so the purpose of my lab here is to compare the two sides of the slinky, the top and the bottom side of the slinky, and determine which side would hit the ground first, or would the top and bottom end converge mid-air and then hit the ground together. And for the fundamental physics principles that I used gravitational force, or the force of gravity acting downward on the object. Then there's Newton's second law that would be used to measure, incorporate things like gravity. And then I use the position update formula as well as the velocity update formula to see the changes of the top and bottom end of the slinky as it fell. And the main result of this lab was that the top end would fall down, but the bottom end would appear as if it's staying at rest until the top end would collide with the bottom end of the slinky, and they would be compressed and hit the ground as a compressed slinky. So as for an overview of the lab, some assumptions I had was that there would be no outside forces acting on the slinky, and that it would have a constant mass and fall in a straight line. And the models I used to measure the position and velocity would be like the position versus time and velocity versus time graphs. And as for the initial conditions, I estimated that the height of the man who held the slinky that he was 1.7 meters tall, and I said that the top end of the slinky was at the same height as the guy in the video, which also 1.75 meters, and that the bottom end of the slinky, its initial position would be 0.6 meters. And as for the system and surroundings, I said that the system is just the slinky, and the surroundings is the hand releasing the slinky, as well as gravity and air acting on the slinky. So this is the video that I used of the slinky. And then I also used Tracker to map out the position of the top and bottom end as the slinky fell down. And then here are the graphs that were produced. So as you can see, the top end would fall at a constant rate or a constant velocity, and the position would just steadily go down. For the bottom end, the position would stay still until it collided with the top end, and the position would decrease and the velocity would change. And then I also modeled the real-life observed data with an experimental or computational one through GlowScript. So I created a top and bottom end of the slinky. I created variables for those, and then I set initial positions and initial velocities for them. And then I added velocity update formulas and position update formulas for both of them, as well as incorporating force of gravity and force of drag. So this is what the graphs look like. As you can see, they're pretty similar to the observed data. So here's a comparison. So basically, yeah, like the top end would go down at pretty much like a constant rate, or like actually in here it's like accelerating, but the position is going down basically. But then for the bottom end, the position would stay still until the velocity would change, and then the position would decrease. So some possible errors in this experiment was that I didn't account for air resistance, and I had to estimate a lot of the heights and lengths of the position of the end of the slinky, as well as the height of the man standing. For my what does it mean question, I asked why did the bottom of the slinky stay still? And I said that while gravity acted downward on the top and bottom of the slinky, there was tension acting upward only on the bottom of the slinky, not on the top. So that would mean that the bottom of the slinky would have gravity and tension acting on it, and they would cancel out, making it appear as if the bottom and end of the slinky would be at rest. And from a what if question, if I continued tracking the position of both ends, what would happen to the top end of the slinky once it hit the ground? I said that ideally it would compress and expand slightly due to a transfer of kinetic energy to the ground and the elastic nature of the slinky. And that concludes my lab. Thank you for listening.